we were more than 180. I suppose the people are going to come back. Just a few words to thank also the organizing committee of this event, which has worked with me, particularly Cormac O'Keefe, which is Director of Digital Learning at INSEEC, Julia Pidel, who is the head of international affairs at INSEEC, Sophie Broquet, who is at Sustainable Development Direction of INSEEC, and Yasmina Abdelalbar from Research Center of INSEEC. So thanks to have helped me to organize this event, and thanks to all participants. And Cormac, you can start.
Fantastic, thank you very much. All right, so we're going to start this afternoon's roundtable on how do technology, artificial intelligence affect teaching, learning, and assessment. So today we have Nabil, Denise, Benoit, Bryan, and François, and I'll be introducing each person separately. We're going to have 10 minutes for each talk, and I'm just going to interrupt just towards the end to give you a gentle reminder when there's 2 minutes left. And then we're going to have a Q&A session at the very end. So if anybody has any questions, I'm going to be monitoring the chat feed, and I'll be noting down some questions that we can ask towards the end. So our first speaker today is Nabil El Khadi. He's Vice President of Academic Affairs at Kwazambi International College, as well as founder and CEO of Innovative Solutions and Management Consultancy. Okay, Nabil has over 15 years of management experience in higher education and research centers, and also worked in corporate projects using AI, online payment, and automatic translation. So today, Nabil will be sharing his vision of impact usage and the future of AI on technologies on higher education. So over to you, Nabil. You need to turn your microphone on. We can't hear you.
Sorry.
Great, thank you.
Here we are. Yeah, so thank you very much, Cormac. Thank you all to the INSEEC for this wonderful event. It's my pleasure to be with you today, and I'll do my best to comply with the 10 minutes granted. So as you know, today technology is everywhere in higher education, and that's what allows us to move to what we can call or qualify as digital education. We know all about a lot of tools, where other tools that allow synchronous learning, Google Meet, Blackboard Collaborate, MS Teams, and other. A lot of tools for management information system and, learning management information system, Moodle, Blackboard, Canvas, and other. And of course, we have all the SIS batteries. I just picked some example like Oracle, PeopleSoft, and others, as well as specified tools when we are using for simulating some lab like Clubsters and others. So this, let's say, the first impact of technology, and it came to the education to do a lot of things. I'm just sharing with you here some impact and some results, in fact, with the digital transformation at KIC here, for example, with the pandemic, when we were in a situation of emergency digital transformation. It had an immense impact and positive impact on student attendance, on successful examinations, and a lot of such kind of things. We had more than 99.1% of exam success in terms of connectivities, less than 1% of technical issues across 4 semesters of digital transformation. Also, the technology allows us to be more student-centered, and one of the areas I believe in many countries in the world we are struggling to let the students engage in learning and engage in using for digital resources. When we shifted fully to ebooks, and with the pandemic, we have seen between 100% to 300% improvement in the result of the users. So we need to keep in mind that technology is not a target in itself. Technology should allow us to move from the digital learning to what I qualify as a smart learning, when the experience of the learner is much more interesting, when they are using the resources in a better way, when they are learning and having a much flexible journey with a lot of importance and a lot of positive engagement, and as well as more facilitating and making easy their engagement with us. One of the things we are seeing last 5 years is artificial intelligence emergent in a lot of sectors. Few statistics about artificial intelligence. If we look to 2019 and the number of private venture in the artificial intelligence, whether in Europe, USA, and China, we can see that, we are in a round of 250 to more than 700, private global actors. And we can see that the investment in that regard is going hugely. And we can see that the three countries, are the three areas of the world are competing together. Still, in terms of field impact, USA is still having, a much more impact in that and much more citation. However, in other factors, we can see that China and Europe are really doing very well. The number of academic publication in artificial intelligence related field in 2019, the first is China, followed by, very closely by Europe and then USA. The number of supercomputer qualified or classified as among the top 500. Also, we're going to find China, followed by USA and Europe, almost in the same area. So artificial intelligence today is a must and is everywhere. So where we can use artificial intelligence in higher education, in addition to the digital tools that we can use here and there? Well, I try to represent here the cycle. And in fact, artificial intelligence is everywhere. We can use artificial intelligence tools for screening and selection. I know of a couple of schools, even in France and in Paris, using the same. We can use it in course delivery, in feedback, in simulation, and in assessment. And of course, we need to keep in mind that all those tools are having one target: making the journey of the students much more interesting and better, high quality of educational content, having more focused and engaged people, and moving toward Uberization concept of learning, when we have a full customization in the delivery way and even in the curriculum. And unfortunately, curriculum customization maybe is the area where we still have to work. Today, worldwide, you can see a lot of actors, in edutech, Coursera, Udemy, and other, Blinks Learning, and other, and you can see it's everywhere. It's in Africa, it's in Europe, it's in America. So that's a must, that's a transformation. The pandemic came just, to push everyone toward it and to let even the quality assurance agencies and regulator react to that. In the rest of my presentation, I picked some example where we are using tools. Here you can see a lot of tools used for HR hiring. They're automated tools. I know about many examples when those tools have been customized for student screening. So that's one of the area of the usage. One of the example is in the Arabic University of Kuwait. Then we move to the delivery. We have a lot of examples when we have artificial intelligence tutor, artificial intelligence assistant, and teacher that are presenting or discussing with the students, and a lot of examples are there. I picked just two examples, the University of California, San Diego, and also another example in India, where in fact the students were not even aware that they are interacting with the machine. Student feedback are very interesting, but very expensive. A lot of time to give a personalized feedback. And today, through Blackboard and other, we can use, digital tools. An example in the Deakin University at KSC, we use Kahoot for concept of gamifications, and they were just giving you some statistics on the students' engagement. In one example, we reached even 500, 600 students, which is around a third of our global student population. It is amazing. We never managed to reach that before. We have a health science, and allow me to share with you some video to show you how we are using the high fidelity simulator. It's not just a robot, it's an automated process with artificial intelligence. Maybe I will start with the last one and the one before to see how the artificial intelligence allows students in healthcare today to learn in a better way. So I'll just run this video.
Where's the pain exactly? Pain in the center of my chest. All right.
So as you can see here, the robot is interacting based on the answer, on the question. The questions are analyzed in real time so that he can answer. It's not a pre-recorded scenario. Another example is the following one.
We have one patient admitted at the emergency room with a car traffic accident. His blood pressure is 90/60, heart rate is 140, and his breathing is respiratory rate is 8. Please call for help.
Okay. So can I have some help here, please? Yes. Can you please control the breathing? Please control the breathing. Please, can you please take over the airway? Okay, the patient has pulse, but he's not breathing at a good rate, so it's like 8. Can you please continue the artificial breathing for the patient, please? And I can see that the patient is breathing.
Again, for sake of time, I'll not go through the whole video, but here, this robot, in fact, will react to the level of pressure. It's an artificial intelligence that will sense and react. And this is amazing to allow the student, for example, in healthcare, to be in front of like a simulated case of real patient, and that will not
we have one patient admitted at the emergency room with a car.
I'll move to the next slide. Of course, the exam and the proctoring is another area. I just here collected some of the tools used today for automated proctoring. We have artificial intelligence tool that analyze the environment, analyze the object, give you feedback, give you alert. It's amazing. We are not very sensitive yet to that, and we have some challenging in implementing that around the world, mainly because the students are not ready. And this reminds me of one experience that happened in 2000 in France, where the wireless card was introduced for payment. Consumers were not ready for that. So we need to use the artificial intelligence with caution. We need to prepare the minds. We need to know where to start, because AI will help and support, but will not replace, in fact. The last area is about the curriculum customization and curriculum design. Very few tools are existing today. Unfortunately, we are still putting everyone in the same curriculum, delivering the same content, and doing the same assessment. Today, there are a lot of examples when we want to profile you using artificial intelligence. I can present a Pythagore theorem to you using, a numerical presentation or using graphical presentation. This should depend on you as a learner, and I believe that's the future of education, with integration of technology and integration also of customization. We will use more virtual reality tools, we will use more cloud tools, a lot of biometric, but mainly a lot of personalization and customization for the sake of a better learner journey for our students, for the decision maker of tomorrow. Thank you very much. Here I include just a few videos that you can see and you can, enjoy together. I hope I'm exactly in my 10 minutes, and I will be pleased to answer any question that you might share later on. Thank you very much. You're on mute, Cormac. It was on mute, Cormac.
Thank you. Some people in the chat said they couldn't see the presentation. It was too small. If that's the case, just click on the thumbnail and then you should have the presentation in full view. So thank you. Well, listen, we're going to go over to Denise now. So Denise, Professor Denise Whitelock, is the Director of Technology Enhanced Assessment and Learning at the Open University at the Institute of Educational Technology. Denise has over 20 years experience in designing, researching, and evaluating online computer-based learning in higher education. And today, Denise will be presenting her experience and her views on AI and assessment and the kind of opportunities for teachers, students, and researchers. So Denise, over to you. Thank you.
Thank you, Cormac. Can you see my screen?
No, we can see you though.
Oh dear, because it's showing up as that you should be able to see it, and I've shared it.
If you want to, you can try sharing it again.
Yeah, that's what I'm doing.
If you click the presentation, maybe you need to click on the presentation, or...
Yeah, I've done that, and it was all working fine this morning.
Okay.
Share content. Here we go. Would
you like me to load it, or?
I'd rather run it myself, but let me just have one more go. Third time lucky, hey?
All right, let's go. No problem.
Oh dear. Rehearsals are wonderful, aren't they? Can you see it now?
No.
No.
Okay.
So Cormac, you can switch, and you will be back when you will be ready, or we can send your presentation to Cormac.
I have it. I have it.
To
I'm just going to load it
Yasmina,
now.
okay? To Yasmina. So
Cormac,
I'm
Cormac,
loading it now. Okay. So
Cormac, can you load it, please? Sorry, beg your
I'm just
pardon.
loading it now. It's loading, and it should be ready now. Can everyone see the presentation? You should see it now.
Yeah, fine, thank you. Good afternoon, everyone. I'm sorry about this little hiccup. Technology is wonderful, and I work in the Institute of Educational Technology. It is a great pleasure to be with you today. My institute is using lots of new tools. We have an AVAR, lab, and it's like Star Wars. You know, the professor there can hold out his hand, and there's an image of someone sitting in his hand. However, I don't want to talk about the tools per se. I have a thesis that I want to present with my short talk today, which is we know assessment drives learning, but if you're going to use tools to help in this area and to help us understand teaching, then, we need a good problem. So the first example I want to show you is quite old, when we were talking about a system built in LISC, and I was involved with this, where we're trying to teach another language. This was happening in Kent. There weren't enough tutors, and I think people here in this room know better about learning a second language than I do, and that, if you don't correct errors, they become fossilized. And so the LISC program helped people, this is very early, put their responses, translations in, and to get feedback. But we learned something. It's all very well having an AI system, but what can you learn? And if we move to the second slide, we can see that in this work, the students were given two options. And so they could submit, get some feedback, and then try again and get a final mark. And what we've learned here is, you need unequally weighted attempts, and it's better to weight the first attempt more, because otherwise students don't try enough, and they won't try, and they're not learning as much. Now let's move to another example, and this is Open Mentor. And Open Mentor was a system we built that I'm in a university with 170,000 students who work at distance. And because we're digital, we have lots of data, and that's what's important for AI. And our main teaching vehicle is their assignment. And we were able to use a system where the tutors mark on the assignments, their comments, and give marks. We were able to strip out all the comments that the tutor gave. And here's the system. And it was put into 4 different categories. Category A was praise, comments that included praise, and that's very important and underestimated by tutors giving feedback, especially when students are working at a distance and don't see each other. B were the teaching comments, C were the comments that were questions, and D were the negative comments, because when we train our tutors, and you can imagine on a course with 10,000 students, and there's a 1:20 ratio to tutor, that's a lot of tutors, and you want to make sure students are getting reliable feedback and consistent feedback. So this was to help tutors to have a look at how they were actually giving feedback. So if we move to the next slide, we'll be able to see that it gives some very interesting feedback. And in this chart here, you can see there are 2 lines, 2 bars, the ideal and the actual, because this wasn't about, tutors know how to mark, they know the subject area, but are they giving enough feedback? So because we've got thousands and thousands of students, we can actually go in and use a system where we have an algorithm which we've worked on because of looking at thousands and thousands of scripts, that for the mark awarded here, which was 61 out of 100, that the comments that the tutor was giving, that's the blue lines, you know, weren't what we would expect for this grade. So here is a system, there's a problem. How do you get consistency? How can you support your tutors to give good feedback to the students? Here's a system that uses thousands and thousands of pieces of data that can this sort of feedback that can help support the assessment process with the feedback. Now let's move to another example. This is a piece of research that I undertook with Oxford University because we had an interesting problem. The problem was that we have students coming to us who might never have written an essay for years or done anything like this in an assessment, and they don't get any feedback while they're trying or building the assessment, the essay. And students drop out without support. And the idea was, if we could build a system that could give feedback on the essay the student was writing before they submitted it, supporting them, then the dropout rate would be less and students could move forward. Also, why would you pick a machine to do this? Well, the machine is non-judgmental. It's not going to tell your tutor what you know or what you don't know. So if we take a look, we can see, what does this system do? It uses natural language processing, and it looks at keywords, key phrases, key sentences. And that's what's being analysed in the by this system called OpenEssayist. If you could move on, Cormac, please. So that summarises how it gives its feedback. And we did some trials, and we can move on to show the statistics here using this system. And we found that, not surprisingly, that you are, if you draft more essays, so you get some feedback and you redraft, put it into the system, you get a better grade. But more importantly, we compared the overall module grade with the students using this system to the year before that didn't have it, and we got a significant difference. Now then, you know, research is very interesting in that you find things you weren't expected. So what we did then is we thought, we've got key sentences, and if you could go back one, Cormac, please. If you've got key sentences, you can actually put them into a graph using a cosine rule. And we put in an essay that won a prize, a very important essay. You can see here the Stanford University Prize Boothe essay. And the nodes, the colours of the nodes, we call them rainbow diagrams. The red represents the conclusion sentences, the violet the introduction, and the other colours of the rainbow, the main text of the essay. You can see here that the coherence, that a prize essay, a good story, has tremendous coherence, as shown by this cosine rule in these nodes. If we move now to an essay, a high grade given to a student at the Open University, we can see it's not as good as this, you know, prize essay, but we've got the introduction, conclusion, and main text coming together with some outliers. Now, if we look at a low essay, graded low, you can see that there is more dispersion. So the low grade is not so coherent. So we looked at these and thought, goodness, by eye, we could probably work out how, what the mark might be for an essay using this representation. So we did that, and we looked at the statistics, which we can show you in the next slide, that we could see from, and we did a proper trial with people looking at these these diagrams.
Just wait 1 minute.
Okay.
Go on slightly over time. Okay.
So that the essays rated as high would be expected to receive 8.56 points and better. But also we've been working on Tesla, which is an adaptive trust program where you've got AI giving video feedback, audio feedback, keystroke pattern detection, anti-plagiarism and forensic analysis. And we've trialed this with 8 partners in Europe. And this is helping us move forward with the COVID situation when we need to carry out examinations and be sure that the students are who they are when they're taking these examinations at home. We've heard about chatbot recommender systems, and we're working on assessment from your own personal robot now. But the challenge, I think, and this is my final slide and my final point, the challenge for us is that we use AI because we use predictive analytics at the OU when people are working online to see if they are going to drop out, they're not, and we can give them extra support, is that it's representing the analysis of learning that can be readily understood, both by the tutors, the teachers, and the students themselves. And AI needs a good problem to help us move forward with teaching and learning. Thank you.
Thank you. Thank you very much, Denise. That was incredible. Okay. Okay, so thank you very much. We have some questions at the end, and I've noted some of the questions. Now I'm just going to load up Benoit's presentation. So while I'm doing that, I'm just going to introduce Benoit Praly. So Benoit Praly is the founder and CEO of Domoscio, which you may have heard of. It's one of France's leading adaptive learning and personalized learning edtech companies. And so Domoscio work on the relationship between cognitive sciences, AI, and how you can make personalized learning programs to change the way that learning is done in higher education and professional training. So I'm just going to load up Benoit's presentation now. And you should be able to see it in 5, 4, 3, 2, 1. Here we are. Okay, so Benoit, over to you, please.
Okay, thank you. My mic is on, so you should be hearing me. Really nice to be here. A big thank you to the organization, INSEEC, you, and every one of the participants. I hope you will get along with the French accent. So Domoscio, and I'm really happy to be here. I was a researcher, and now I would say just a CEO of a company, but I took from all the time I spent studying and studying how the memory is working and stuff like that, a vision that we could do more with AI, with digital learning first, and then with AI, in order to enhance the learning of students. So maybe a few words about Domoscio. So Domoscio is a French startup that works both in the US, in France, in Spain, and also in the UAE as soon as it gets started. And it's a small company. It's just 20 people. And why is it so small today? Because we are just doing technology. It's really important for us to be a full digital player with AI. And we don't do content, we don't do LMS platforms, we don't do actual training. What we do is to, I would say, empower an existing learning environment with a specific algorithm in order to enhance the user journey, and the user is mostly the learner. So in my opinion, and in the few slides that are next, I would like to emphasize two main use of AI. In my opinion, AI is really at best when working before class or before learning online, and working after learning in class or online. And why is it so? Because I think that first, AI will never replace the teacher. AI will make sure that when the student comes into the class, he has the proper level of mastery regarding the different concepts that will be taught during the class. Does he have the prerequisites or not? And then after the class, AI will help him to remember, to better remember and consolidate what he has just learned during the training, so that it is not something that will be shallow and be forgotten in 1 week or 1 month, but it's something that will be stable based on a strength and a strong memorization. So in my opinion, AI main challenges is before the classroom with adaptive learning, and after the classroom with learning reinforcement. And what's really interesting with the presentation of Nabil and Denise is that what we are seeing right now is that the sanitary crisis that we have experienced and that we are still experiencing is a speed process of dealing data and I would say producing data. And all this data will be the fuel for proper and performing AI. So the three main questions that I would like to tackle is how do we integrate AI in an existing environment? It's not something that is straightforward. For what benefits and what are the prerequisites? So dealing with adaptive learning first. So how does adaptive learning work? Adaptive learning is actually a loop. You will start with a learning goal that is most of the times that is an academic, I would say, expectation. So based on the student and where he needs to be in terms of academic expectation, the adaptive learning is the journey that will take a student from point A, where he stands now, to point B, where he should be standing at the end of the year. And the idea is to first do a skill or analysis through assessment, computerized adaptive testing and stuff like that, so that we know where he stands at now. And then we will use a hybrid recommendation system, a bit like when you browse on Amazon or Netflix. You will see, based on what you have done before and what some people like you have done before, it will make a recommendation. So this is exactly adaptive learning. Based on where you stand at and where you need to go, adaptive learning will try to do recommendation all along the way that will produce data and be able to adapt and to reassess whether the student is progressing or not. What we have experienced so far with adaptive learning is that when we take a population A without adaptive learning and a population B with adaptive learning, we are able to I would say, access the same academical objective, the same pedagogical objective, but with less time. And we have been able to show that we can save 37% of time with adaptive learning, whether with no adaptive learning. So it's really important to see that with adaptive learning, the learning journey of the student will be better tailored towards his needs, towards his current mastery, and he will be more engaged and more inclined to go to the end. So this was the next slide, sorry, Cormac. Yeah, this one. So with adaptive learning and without adaptive learning, and adaptive learning can save time toward the reaching of the objective. Then a focus on learning reinforcement. So let's say I learned something now. The fact is that in 1 month from now, I will have forgotten up to 80% of what I've learned. And this is a major issue for students that will prepare an exam, but also for corporate training. And the answer is actually quite simple. And now when we see and we study what the research says about memorization, we are able to say that the best way to memorize on the long run is to use a spaced repetition system. Spaced repetition system means that after the assimilation of a concept, you will have few reminders that will be spaced in time. And as the device and the brain is performing well, I would say, the timing, the spacing between the two reminders will be larger and larger, which means that if I learn something new now, I will probably receive in 2 days from now a first question. If I answer right, I will receive a new question in maybe 10 days, and then 3 months, and then 1 year and a half. And this process will produce data that will help us to personalize the next due date for each student, so that each student have a personal learning and memorization path. A few numbers about learning reinforcement. So on the next slide, what we have done also in France with research labs, we have taken a population A without learning reinforcement and group B with the learning reinforcement. And what we have been able to observe is that if we do a standardized test 3 months, the same one for the two populations, 3 months after the training, we will have 46% more knowledge retention for the group with the learning reinforcement. It means that it works, but now we need to actually make it work in an existing environment. We have a technology that is that has been proven in terms of efficiency, but now we need to make sure that if we put that kind of technology into an existing learning environment, it would fit. And this is the next slide. I was asked by Cormac to do something like how to and how to not to. And how to, I would say, AI is best when used to address student autonomy in order to ensure that the students will have an homogeneous level before starting the class. So making sure that when starting a year or starting a class, the student have the proper background in order to take the class. Otherwise, it will create dropping out, and this will be really bad experience for the students. It's also really interesting to help the student to better prepare for the examination, so that we can use the data in order to tell him what level he needs to reach in order to statistically take the exam, and also to center the teacher action.
So Benoit, your microphone, it turned off. So, okay, you're good. Your microphone's off for some reason. Okay. Yeah, can you click on your microphone, Benoit? Because for some reason your microphone is off. I can't activate it. Yeah, cool. Yeah.
Okay.
That's good. You're good. You're good. Yeah. Yeah, you're good.
Okay. Sorry.
I think just we're almost out of time. So just
okay.
Just 30 seconds.
Okay.
Left. Thanks.
Perfect. So on the previous slide, I was explaining how to and how not to. In a few words, I think how to is to better address the learning of the student, and the not to is to replace the teacher. And this is not something that will go on the one go. It is not something that will be at once. It is an ongoing process in which you need to exerce change management for the teacher and the students. And I think the opportunity here is huge. It's empowering teachers and learning resources with explainable, transparent, and ethical AI and technology. And I think that these three words are really key. The AI needs to be explainable. What kind of data do we use? How do we use them? Transparent, which means that it needs to be fully acknowledgeable, and ethical, because we know that with AI, based on the set of data that we use to train, it can be an issue. So thank you. And
great. Thank you very much. That was brilliant. I really enjoyed that. Okay. So next up, I'm just going to move quickly. We're going to move to Bryan Maddox. Okay. Present. Great. So now just going to load the presentation. So while I'm just loading up the presentation, Bryan is a lecturer at East Anglia University and also the founder of Microanalytics, which is a company that specializes in looking at learning and assessments with some pretty innovative technologies. So I'm just loading up the presentation now. And just a quick reminder for those of you who only see a small version of the presentation, It'll be the thumbnail, so you just have to upload it. You just have to click on it, and then you should be able to see it. Just loading presentation now.
Okay. Thank you very much. Can you hear me all right, Cormac?
Loud and clear.
Okay, wonderful.
Okay. I'm just going to cut my microphone, and then when you see my camera back on, it means you're out of time. Okay, right.
Thanks very much. And thank you also, thanks Cormac for the invitation to present, and also to the other presenters today, really engaging, interesting topics. So my name is Bryan Maddox, as Cormac has said. The organization the spin-out company I run is Assessment Microanalytics, Cormac. And my background is originally, apart from an educationalist, also as an anthropologist. And for the last decade or so, I've been working in the area of educational assessments, really trying to apply observational techniques to better understand how people engage with assessment, particularly digital assessments, online assessments, etc. So it's using observational techniques of various kinds and various digital techniques and observational techniques to find out how people are interacting with online platforms of learning and assessment. So that includes conventional areas around user experience, but also broader perspectives on assessment, interaction, and reception. So why this is an issue, I think, an interesting topic to look at, is that when we're dealing with AI-based systems and various kinds of computer-based assessment, we're now in next generation assessments. We're no longer dealing with, as we've heard very nicely today from the presentations, we're no longer dealing with sort of page-turning technologies. The assessment and learning platforms that we're dealing with are very much interactive. So we're actually dealing with interactive, dynamic, animate interaction with computers, with technology. So we're dealing with, it's a kind of interactive process with non-human actors. I mean, I use the term non-human actors in the broadest sense, where we're dealing with algorithms, we're dealing with AI-based systems, and it's that interaction, I think, which causes quite significant, what we might call mode effects, mode changes, as we move from a static type of assessments, whether they are paper-based or computer-based, towards these dynamic and interactive assessments. Okay, thanks. Next slide, please, Cormac. Thanks very much. Okay, so there's a nice quote here by Stoffler, Rosen, Bolsonova, and von Davier in a recent paper about the assessment of collaborative problem solving. And they talk about disruptive technology in assessment. And I'll just read it because it's just quickly to read through it. The role of technology in advancing the field of education is both disruptive and promising. We've heard a lot about that today. Technology continues to allow us to explore areas of educational learning that were previously obscured and to provide insights that were previously not accessible. So in that area, we have both the promises of digital technologies, and we've heard a lot about those today, including things like improved user engagement, online and remote learning, things which are super important just now during the pandemic. We've talked about personalized and rapid feedback and content delivery. So those are all very positive aspects of this disruptive technology. But we're also dealing with disruption that can be sometimes in a negative sense. So we're talking about interaction with algorithms and AI-based systems, which are essentially black boxed in the sense that the end user, is not necessarily fully aware of the black box content. So how do the algorithms work? How are they optimized? You know, how do they interpret our behavior? And also how we they perform in the wild. So when people are interacting with those technologies, then they have to anticipate how these non-human actors are actually going to work. And I've done a little bit of work recently looking at the chat groups of students in higher education when they take online assessments, AI-based assessments. And it's really interesting to hear that what people have to say in those chat groups as they anticipate how they interact with the AI-based system and how the AI-based system will perceive and interact with them. So I really like Benoit's point about AI-based systems of learning and assessment being explainable, transparent, and ethical. But actually, I think, although we might want to aspire to that actually many AI-based systems of learning and assessment are actually not transparent. They're not explainable, and they're not always ethical in the sense that we haven't always done our homework in demonstrating through, for example, validity practices, that those systems work equally well for diverse populations, etc. So from the point of view of the student and teacher, those are good aspirations. But as we partner with AI-based systems, as we partner with non-human actors, it's not always clear that they are as transparent and so on as we might hope. And that requires extra work for us. And AI-based systems are very intensive in terms of time and resources. And to add another layer about validation and ethics is a commitment that not all organizations want to make. But I would say it's a very important area that we really need to work on. And I'll give some examples of that in a minute. Next slide, please, Cormac. Thanks so much. So another short quotation here. I'm an academic. I share quotations, other people's work. This one is from Ryans and Fredrickson, cited by the earlier paper that I mentioned. Where they say, occasionally the product of performance is not measurable apart from the performance. Playing a musical instrument is an example of such a case. In other instances, both performance and process may be measured by judging an individual proficiency. And that quote highlights a lot of what we're doing. We're not really doing with the result, the score, as an end result of someone's educational performance, but we're dealing with process-oriented data. So process data as it's known. And when we think about process data, we need to think very carefully about which data we want to collect and how we want to interpret and use that data and how valid is that data. So in terms of uses of process data, there's a number of different purposes we can put it to. So for example, it can help in informing the design of test items and learning platforms. We can use process data for quality assurance and for user experience. We can use it to validate assessment results as a sort of form of triangulation, but we can also use it as extensions of the test. And that area of extending the test through AI is very much the sort of techniques which are being used these days in so-called next generation assessments, where we're looking at process data, whether it's clickstream data in log files, or whether it's broader multimodal data, for example, around somebody's emotional response, perhaps their gaze, what they're looking at, what pages they're looking at on the screen, etc. And we're using that not just to validate our approach, but we're using it to make inferences about performance. And that might be something very simple, such as, is somebody engaged or not with the task? But it might also be wider issues to do with their performance. So the last slide, Cormac, thank you very much. You can go on to the last slide. There's this question about stealth assessments, because this is the digital transition and the move towards AI-based systems is a really profound shift in educational teaching and assessment. In paper-based systems, people knew the marking schema, they knew the marking criteria, But very much now we're moving towards systems where it's not always transparent and explainable to the end user how we're interpreting their responses and using them to generate inferences about test performance or engagement. So we're dealing with, this is really important because the end user is not a single person. We sometimes think of the user, yeah, but actually in all of our work, we're dealing with diverse users. We're dealing with diverse populations. And so when we do design around AI-based assessments and learning, we have to think about things like ethnic diversity, neurodiversity, cultural diversity, and how we interpret the different responses and how the AI system interprets the different responses of the participants. And I'll give one example to finish off with. There's a very nice example in the research literature about the use of avatars in AI systems. And it's been shown that if an avatar matches with your ethnicity, you're more likely to engage with that avatar. But if the avatar is not of your ethnic background, you're more likely to become disengaged. And it highlights the fact that we're dealing with interactions with non-human actors. Cormac, that's the end of my presentation. Thanks so much.
Okay, brilliant. Thank you very much. That was fascinating. I really enjoyed that. So now we're going to move on to our last presentation, and then we're going to have a few minutes for questions and a discussion with the presenters. And so now our next is from François Stephan, who is the Dean of INSEEC's Engineering School, ECE. And so as well as like a background in IT and product development, is also a background in research and mathematics. So here we are, presentation. And now, François, it's over to you.
Thank you, Cormac, and good afternoon, everyone. I'm very pleased and honored to be part of this panel today on how do technology and artificial intelligence affect teaching, learning, and assessment. My presentation will be two sides. First, what is the impact? What does this new context of technologies have in terms of impact for what has to be taught to the students or learned by the students? And what is the impact of the technology on the way things are taught as a complement of what has been said before by my colleagues, panelists. Next slide, please, Cormac. Yes, and the next one. Yes. First of all, when we talk about tech, we used to talk about new technologies. Indeed, now with the speed of development of technologies that is fueled in particular by the Moore's law of its equivalent, which says that there is an exponential growth of computing power. And now we begin to understand what it means exponential, unfortunately, thanks to the COVID crisis, right? So now all technologies are new, in fact, and we more and more talk about deep technologies. And what is deep technologies that is what defined by Hello Tomorrow and BCG? Deep technologies are technologies that have a strong link with academic research. And again, if we look at the context of the COVID crisis, the messenger RNA is the perfect example of a deep technology because it's a strong link with academic research that was started 20 years ago. But it took 20 years and billions and billions of dollars or euros to make it an industrial application and to make it a tool to save the world. So really, our world needs deep tech, and the conditions are here today to develop, to use those technologies, and they are here to help to solve the main issues of our world, which is more and more complex. And let's talk about what has been talked before about the 17 Sustainable Development Goals stated by the UNO. To solve that, we will need more and more science and more technologies. Next slide, Cormac, please. Thank you. So again, like Hello Tomorrow and BCG said, let's say that deep tech is a new tech, and since it's a new tech, they require new skills and new ways to acquire those skills. Just name a sector and you add tech to this sector and you have a tech. EdTech fintech, insurtech, medtech, food tech, and so on. I think every day there is a new something tech that appears. So, of course, this is marketing, but it's not only marketing, there is a reality behind that. Surprisingly, as it may look, when you ask deep tech entrepreneurs about their major issue, their major challenge, it is not the complexity of the technology, but that comes number one, but indeed it's the time to market. And this is why they consider that the design, management, and business skills are the most critical ones that they need for their business development to be a success and to develop their solution. So, however, we must remind that technologies, deep technologies, are very complex, and they need highly qualified skills, of course. And on the slide you have a few examples of those, and those skills need to be developed, and they are more and more complex. And since those technologies develop very rapidly thanks to this exponential growth, there is a challenge of how to keep up with that. For academic institutions, how we do keep up with the pace of technology development. I think one answer is a strong link with the academic world, and I think a group like INSEEC that has both teaching activities and research activities, I think it's key for the success for our students. But on the other side, I think that let's say that any engineer, any good engineer, should have a fair amount of business, design, and management skills. And on the other hand, any fair manager, designer, business developer now needs to have a good amount of skills on technologies. So now the question is, where do we put the cursor? What is the dosage? And the answer is it depends on the desired profile. You need maybe a very strong specialist in AI development or AI management, but this guy will need to have some skills in management and design. But maybe what we call a data management officer in a large company that will develop and manage data transformation projects, he will need some skills in data management, but not to be a specialist, and the cursor will be more on the right-hand side. So the idea is really in all the training track, I think we need to have this in mind and to put the cursor in the right position. Maybe next slide, please. So,
excuse me, I'm just going to reload the presentation.
Slides.
I'm just going to reload the presentation because
okay. So let me continue. Okay. So let's focus a little bit about AI because I think this needs some specific attention because more and more political and business leaders in the world now say that the future leaders of the world will be the one who will be leaders in AI. Just look at what China is doing, what the US are doing, and what Europe is let's say, trying to do on AI. It means to be leader in AI, it means to design AI, to develop, and the capacity to apply AI in one's economy, in one's country. So in terms of learning challenges, I think AI puts some points. I think that it is very important to have in mind those points. I think there is no need to learn what, yes, the next one. Yeah. There is no need to learn what AI can or will be able to do with us. So it's slide number 5. The previous one, please.
Yeah.
Yes,
yep.
Sorry.
Great. Okay, sorry about
that. But the point is really to our students need to learn how to design and develop AI. So there's strong engineering skills to work and collaborate with AI, to use this new tool, those new objects, to understand and choose the correct AI tools on the shelves, and of course to monitor, to regulate, and to master AI. So in another way, I think something that François Tadei said, it's to learn how to cultivate and apply one's creativity, because this is what will differentiate the human from the AI algorithm and software. And of course, very important to continue to learn how to collaborate on a large scale, which has been the success of the development of humanity. If you have read the Yuval Harari book, Sapiens, this is what he says. So I think we need to continue to teach that to our students, and also to learn how to learn continuously. I think this is very, very important. Maybe to almost to finish. Next slide, Cormac, please. The second point is how can we leverage from technology of the way of teaching. So I will not repeat what has been said before, which is very, very interesting. To my point of view, there are three streams of technologies: online interactive technologies that have been experimented now recently, of course, on a large scale, data science and AI that was presented before, and cloud IT infrastructure. Cloud is a major now technological platform, and just look at the news today that Jeff Bezos has decided to step out. But what is very important, that his successor is the leader of the cloud services of Amazon that represent 2/3 of the profit of Amazon. This is a very important information. So what will those technologies bring, and are bringing already, as was presented, adaptive, personalized, and blended journeys, all the AI tools, chatbots, analysis of learning data, etc., and more, I think, more horizontal and peer-to-peer approaches. And maybe my last word, so next slide, Cormac, please. I will please ask you to allow me to share you my view on the future of higher education institutions. I'm making an analogy with the terminology that was invented more than 10 years ago by the NIST, the US National Institute of Standards of Technologies, about cloud computing, you know, software as a service, platform as a service, etc. So I strongly believe that the institutions, the higher education institutions that will survive and thrive in the future will be those who will be really higher education as a platform. It means that they will operate as a platform, in a two-sided platform business model between students and the job market, in a model that was described, for example, by Jean Tirole and his teams by the Toulouse School of Economics, which is the business model of the GAFA and the BATIX, for instance. So it means new business models, new user experience, and the users are students and the job market. And last but not least, such a platform must be supported by a very, very strong, up-to-date, state-of-the-art data and AI-driven digital foundation. Thank you very much for your attention.
Okay. Thank you. That was amazing. I really enjoyed that presentation. Okay. So great. Now everyone's back, and just going to go to the gallery mode. Right. So now what we're going to do is we have a few minutes now to ask some questions of the presenters. So what I have some questions that came through on the chat. So I've got some questions for you about, say, AI and data. So there's some questions here, and this is open for anyone to respond. Some questions here about, have there been any studies that have done where they've analyzed AI assessments to be as effective or not as effective as human-based assessment? Perhaps Bryan or Denise, if you're a specialist in assessment, what do you think about that?
The question isn't quite posed to the answer that can be given from the data. That's because anytime a new tool is used, it is to say, is it equivalent, so we do no harm, or can we see, some improvement or whatever? So that there is no straightforward answer to pick on the data with, because there are different ways of trying to address that question. So I'm being essentially very honest here. It's not as, sorry, I can't say anymore. So
okay, no, that's no, that's great.
Quite
okay.
Like that.
That's fine. We have another question, and this might be a question for Nabil or François, and also Benoit. These data-driven approaches often require fairly sophisticated technologies, skill sets, and teams in order to implement them. So for higher education institutions or even schools that are looking to adopt these kind of approaches, what are the major challenges or that are faced by institutions in order to implement and adopt, if they want to use more data-driven approaches? What's stopping them from doing so, and or maybe doing it badly, if I were to say that? Okay, François.
Maybe I can start part of the answer. I say the major challenges for those institutions is to become corporations as others, even if they are public, but they must go to their digital transformation as any company. So this is an issue for any company to be supported by data and AI driven foundation. I think that's very important. So the challenge is really to move towards an enterprise approach with a platform approach. And of course, a major challenge is to get those skills in-house, not only, of course, train those, but have those skills inside to fuel their development.
Okay, fantastic.
A few inputs.
Yes, please.
If I may. Yeah, I think for educational institution, the first challenge is an instructional design one. Because when you're gonna embed the tools of artificial intelligence and any smart tools in your, digital transformation, as well said by François, you need first, to design differently, to think differently about your curriculum, your way of delivering, your way and assessing. And that's why academicians are facing the challenges. It's not on integrating the tools on the technology. Those are in general straightforward, and there is a very clear way of guiding and helping, but you have to think differently. And that's really, and by experience, I can tell you, are transforming 120 courses to embed artificial intelligence and blended learning. And sometimes it's very difficult to convince the academician that they have to think differently. So I believe instructional design with all the steps from designing the course, delivering it and assessing it is the most important challenge, and not the integration of the tools. Last comment is, you need to be smart in choosing what tools. Do not use technology just to use technology. It's not an FA mode, It's not, oh yeah, let's do as everyone. You need really to choose a tailored for purpose to make the journey most important for the students and most easier. Thank you.
Okay, thank you. Yeah, they're really great points. It's like the famous quote by Chris Bigham: "We shouldn't have technological solutions looking for educational problems." That's entirely true. Yes.
Yeah, just to say I fully agree with what have been said, and I think using AI needs data, and dealing with learning, we don't have big data. What we do have and what we need is smart data. So this means that data needs to be tagged and contextualized, and the more context we have, the more metadata we have, the better will be the AI. So dealing with skills frameworks, dealing with information regarding the students, where does he consume the content, and all this kind of data is really key. And I think the best way to start using AI is to build a strong use case somewhere in the university, take a course, start small, and then grow big and industrialized. And this means change management at all levels, as François explained.
Fantastic. That's a really good point, and like a very clear example. So in that respect, should learning designers or universities start becoming, in some respects, data scientists in order to better understand what they're dealing with?
Yes, if I may. Sorry.
I'd like to build on Benoit's point that it's not just data. What is going to be king in the future is the metadata of the data. And that is going to make a big difference, especially in COVID, when people are trying to move online. We're trying to build resources for people, free resources and whatever. But if you're trying to use, as Stephan mentioned, an Amazon model, where I can go and collect some courseware, some assessment, some learning design, I need that metadata on that data so that we can actually scrape it off, do something with an algorithm that is very quick and easy. Thank you.
Okay, that's a really good point, and I think that's very similar to what Benoit was saying too, in terms of the context and kind of like rich context-based data as well. And so there's another question here about say ownership. So if we're moving to cloud-based platforms, and lots of the leaders in AI-based technology, because it's quite expensive and you need big data sets to make it, tend to be owned. The technologies tend to be owned by Amazon, IBM, Google Cloud Platform, and so. There are even some scandals about Turnitin in terms of analyzing student corpuses. So what are the challenges that universities face with privacy laws and respect for students in terms of who owns the data, who owns the metadata, and how can that be reused responsibly?
Maybe if I may start an answer, again, same challenge as a car manufacturer that decided to partner with Google or with Microsoft for the future cloud-based services in the car and in the mobility. Look at Renault that has partnered with Google, for instance. Exactly the same question. Very difficult question you ask, very critical, that has to be solved. Or maybe a choice for European higher education institution is to move to a European cloud provider. Maybe. But the point is, you need performance, you need scalability, you need security, but of course you need to address these data issues, which is very, very complex and very important.
Yes, I couldn't agree more. I think the project that Denise was working on, Tesla, was like the idea to make a European-based anti-plagiarism system and authenticity system that your institutions can have more control over, precisely. And also we saw a recent scandal at Google where one of the chief data scientists was fired for a natural language processing based project, just in terms of the kind of methodological questions around how the data were used and constructed. Great. As we have a few more minutes left, and we have another question from over here. So one is that in terms of creativity and originality, what's the relationship between AI and assessing and analyzing creativity? Because often we say that that's the limitation, you know, that, for example, AI can't be as creative or can't give the same quality and rich feedback that a teacher would give. In the same respect that even if a computer can give rich feedback, will it ever replace the kind of feedback that you get from a teacher that you really respect and like?
May I?
Could I have a go at answering that one, Cormac?
Please,
Sure.
Please do.
Yeah. I mean, there's been quite a lot of new research and innovation going on in assessing creativity over the last few years. The OECD and its partners, some of the large American organizations have invested quite significantly in developing approaches towards assessing creativity. I think one of the key things there is about that they need to develop a framework. You know, a teacher can observe somebody in a class and they can pick up intuitively using their human techniques, their human understandings, whether somebody is being creative. In order to assess it, we need to take a step back. And it's very anthropological, actually. We need to think, what does it actually mean to be creative? And then we need to build reliable constructs and frameworks. And that's the starting point. So I think, you know, to take that teacher knowledge, for example, what are we looking for with creativity? And then to translate it into a framework and a construct. That's the first step. And then the AI-based system stuff comes later. That's relatively easy, I think, in comparison to actually having that meta-awareness of what do we actually understand by creativity? What is it we're trying to capture?
Okay, thanks. That's a really great answer. So we have 2 minutes left. Would any of our speakers like to have some final words or any final closing comments? Benoit? Over to you. You need to turn your microphone on.
Yeah. To get back to the ownership and maybe to give a few words of mine to conclude my expose, I think what we need is more initiative like what you are doing, because it would foster a better collaboration between research, industry, and universities. And I think this is key in order to ensure the ownership and the transparency of the algorithms. And I think one key word is interoperability. I think that going from a system using AI to another one that is owned by another company needs to be interoperable. It means that we need to be able to to exit some data set from a system to another one, so that the student is not caged into only one system, and that the value that he is creating for one system is operable with other systems. And I think that this is key, and your initiative today is really important to do so.
Thank you, Benoit. That's an amazing point. It's a little bit like XAPI for data models for e-learning. So we need to have some sort of interoperability system. Yeah, it's great, and kind of standardize it. Okay. And also standardizing, but leaving place for creativity and difference as well. Well, listen, thank you very much. That was an amazing discussion. I really, really enjoyed that, and I'm sure our participants did. Just a final note is that we'll be sharing the video of this presentation, and also most of the presenters have given permission to share the slides. So thank you very much. That's very generous of you. And so we'll be able to email those to those people who participated in the session. So thank you again. Have a fantastic afternoon, and we're having a short break, and then we'll all be coming back here at 3:30 for an amazing conversation on co-modal or high flex teaching. That is to say, how do you have a curriculum where you can have students participating by virtual video conference and face-to-face teaching, and giving students the choice of being physically present or off-site. And that will be at 3:30. So thank you, and enjoy your break. Okay. Thank you.
Thank you.
Okay, bye-bye.
Thank you, bye-bye.